Okay, all right. So, so for the next part, you need so remember that we already learned that there's two types of electricity, right? We learned that there's static electricity and there's current electricity. Static electricity is the one where you rub and then you get the plastic to be charged lah, right? And then you draw the electrical fields and all that, right? They are related. Static electricity and current electricity, they are related. Got some relationship, but for now we think of it as two separate things. Now we learn some basic about static electricity. We will now go into the basics about current electricity. So that will be today's lesson. So today we will focus on learning about current, potential difference, and resistance. Okay. Are all of you clear about the difference between these three? Or is there anyone who is still confused? Okay, my question again. Maybe I rephrase the question. Who is not clear? What is these three things? Okay, me. Okay. So let me explain in simple terms first. Then we look at the calculation later. Okay. So inside a circuit, if you take let's say we take a battery. Okay. Battery got terminals, positive and negative. It's very important to know lah, right? Because the existence of positive and negative terminals. My tablet is not behaving properly. Because the existence of positive and negative terminals is what makes the current flow. So when you take the battery and then you connect it to a circuit, let's say this is the wires, right? The wires need to be connected to something to make the circuit do some proper work. When I say do proper work, means that if you connect like this, this is not good. This is known as a short circuit. Short circuit, you are wasting the battery. The current will flow very fast. The battery will spoil, will leak, and nothing is being done. That means no useful energy is being used. So I'm drawing like that because I just want to base nicely and then put something nicely here lah. Okay. So let's say we put a light bulb here. Okay, Chewa, my drawing not so bad. Okay, so let's say here's the light bulb. Okay, so here's the light bulb. So this is connected to the light bulb. Okay, so what's all these things? All right. First things first, you need to understand what current is. Current is something that flows. So you've got electric current. Electric current is what is flowing inside the wire. Like you have water current also. If you go, swimming pool don't have lah. Okay, swimming pool is it's very calm. Even if people swimming there's no current. Right? Okay, current would be like in the sea, in the river, where you can see the water flow. That's flowing, then that's water current. Okay, so in electrical current flows inside a closed circuit. Current flows from positive to negative. Okay, current flows from positive to negative. In IGCSE, sometimes maybe I don't put bracket lah, because these are the important things to know. Current flows from positive to negative. Okay, you also need to know that sometimes another way they say it flows from high potential to low potential. Sometimes they write like that. High potential, low potential means what? That means you imagine, right? Let's say here is the battery. This one contains energy. You all know, right? Battery contains energy. right? Right? Yeah. So sometimes when they write potential, this is a bit complicated. So I try to simplify for you. So the battery actually got what? Battery actually got chemical energy. Chemical energy is a type of potential energy. You all know this, right? It's a type of potential energy. So based on this potential idea, that's why we say current flow from high to low, because you think like, high flow to low, like water flow from high pressure to low pressure. So same thing, current flow from high potential to low potential. So we always assume that positive is higher potential. So that's why you always see current, right? Current, right? When they label, they draw like this. They draw the arrow on the circuit. I represents current. Actually, I should use green color. Why I use blue? Okay. Current, they use a symbol for as I. They draw the current flow from positive to negative. Now, if I'm not mistaken, your book draw the other way, right? Your book draw the arrow is flowing from negative to positive. That one, right, is electron flow. Current and electron flow, opposite direction. Current is because of the electron moving. Current, because what happens is actually inside the dry cell got electrons. The electrons are flowing from negative to positive. So E. So E, I put E negative, this is the short form meaning electrons, yeah? Electron flows from negative to positive. Why? Because inside the battery is where a lot of electrons are. The electrons must go into the circuit, flow, come out, and go into the into the positive terminal. So you think of it as current and electron are opposite. Why? Because when the electron is flowing, current is because of the electron flow, but it behaves in the opposite direction because it's like a reaction to the electron like that. You can think of it that way. Okay, as physics students, you are expected to understand this. Yeah, you're expected to know this. All right. So current flows from positive to negative, but electrons from negative to positive. Sorry, someone has just asked me a very stupid question. Not you guys. Not you guys. Another class. Ask me. So I look at the question like, why you can't ask me this question? Okay. All right. So, what's this? Okay, can follow so far? So what happens is when you connect the circuit, the electrons are flowing. As the electrons flow, it creates current in the opposite direction. The actual truth is, I don't want to confuse you lah. You just think of it as they are actually the current flow is because of electron. But in physics, you write the current is from positive to negative, electron is negative to positive. Okay. So that's current. Current is because of the electron flow. So I'll write that down here. I think it's not written in your book, so I'll just write here for your information. Current flow is because of electron flow. However, in physics, the current flow is opposite direction to electron flow. Okay. I don't put yellow, I cannot read. Okay, I'll put black. All right. Okay, so in physics, we will focus on current. Although you need to know about electron flow, but we will focus on the current. We will focus on the current direction. So that means from 8.04 onwards, until chapter 9, chapter 10, all that, we still focus on current. We still focus on the current flowing from positive to negative. This one is important. Okay. So current is measured, as you all know, you measure it in ampere. Sorry, change it. Ampere. Okay. All right. And I'm not following your book lah, because your book will write down a lot of things. So I will simplify for you. I make it as simple as possible for you so that you will be able to answer the questions, okay? So because current flow depends on electron flow, right? There is a way to calculate current. The formula is written on page 177. They wrote it this way. They wrote it as charge equals to current times time. So charge, what is charge? So you remember that charge is like a positive, negative, right? Positive, negative, that one. In this case, right, we don't look at positive because the only thing that's moving is the electron, negative. So we don't look at the negative charge. We will look at the value of the charge. That means each electron, right, actually got charge. How much is the charge? The number is a bit complicated. Your book never write. Why did never write? They should write, no? Oh, so the book never write. Okay. So it's a lot of people thought, oh, one electron, one charge. It's not. One electron is not one charge. One electron got charge, but the number is very weird. The charge, I write in another color lah. Make it more interesting. Huh? Charge of one electron, actually the number is like this, 1.6 times 10 to the power of negative 19. The unit is C. C stands for coulomb, which is the charge. You see the C there? Like the one some of you did the question in 8.02, that one, right? You know that, oh, SI unit is coulomb, got micro coulomb and all that. That's this C is actually coulomb. Okay. So you don't need to know this number lah. This is extra information, extra. Since your book didn't give you, means they won't test you lah. But I just share this number with you so that you are aware. Because a lot of people keep thinking, oh, one electron, one charge, one coulomb. It's not. One electron, the number is very weird this way. But when you want to calculate the current, you don't take the 1.6 number lah. It's a bit weird. So you just think of it this way. This charge just means how much the total charge electron have. Like if you have one electron, then this number lah, 1.6 times 10 power of negative 19. If you have 10 electron, then it's 1.6, this number times 10 no? If let's say you have 100, then is this number times 100 no? It's the amount of charge that the electrons have, not number of electrons. So how to calculate current? I don't know why they put the formula this way. I think it's better if you learn, you count. If you want to calculate the current, actually same lah, same difference. When you calculate current, what is actually current? Is how much charge is flowing in 1 second. How much charge is moving through one point. Let's say you want to count, oh, how much current flow through the light bulb. Then you count out, okay, how many electrons pass through in 1 second. Then you count the total charge divided by the amount of time. Let's say like you count in 10 seconds, you divide by 10 seconds. So if you count in 1 second, how much is flowing in every 1 second. So the more electrons, more charge, more current. If less electron flow through, less charge, no? Less current. Okay, it's how much charge the electron is carrying every second. Can follow so far? Okay, can okay, so I didn't go through everything on these 2 pages lah. You can if you want, you can read, but I'm just simplifying. I think in terms of what you need to know, this is actually the most important things that you I mean the easiest thing I would say most important. This is the easiest thing for you to help you understand what is current. Now I do want you to just try the questions on page 177, but let me talk about potential difference and resistance first before you try the questions. Okay, I will let you know what homework to do shortly. But let's talk about potential difference because I want to discuss all 3. If you can see all 3 side by side, then it's easier for you to understand. Okay, so this is in terms of current. Now the current, by the way, unit, already you know is ampere, charge is coulomb, time is second. Must use all SI unit every 1 second. That's why just now I keep saying second. Okay. Okay, next, let's talk about potential difference. So I'm going to focus on potential difference now. Maybe I better change the title here, otherwise it looks like it's discussing everything. Actually, just discussing current. So this one now is potential difference. Now, potential difference is a type of voltage. You've learned voltage before? Let me just put the word side by side. Voltage, potential difference. Okay. Do you know what's voltage? Okay, so if you know what's voltage, potential difference is actually the same as voltage law. That's why let's look at page 8. We look at the next page. Topic 8.05. I think what page is it for you? 180, is it? You look at potential difference, they got right there PD short form lah. Because I think malas to write whole thing full. In IGCSE also they write like that, PD. PD potential difference is a type of voltage. So why the name so complicated? Why they make the name so long? Because actually voltage got many different types also. Got different types. The different type, they measure different part of the circuit, but actually it's the same group. It's like how length got different type length, you got length, width, height, diameter, distance, displacement. All of this is same. It's all length, but got different name because it's different way to measure length. So same thing with voltage. Voltage has got a different type. The different name, it refers to different way to measure. So potential difference is one type of voltage. Potential difference, you measure inside the circuit across one of the components. So I'm not going to draw objects now. I will draw symbol because you need to get used to the symbol. So this is the dry cell, as you already should know. And then we have the, okay, we have the light bulb. Let me erase this inside. Light bulb. Light bulb symbol. This one really, yeah, you should know already. You should know lah. If not, you just check the 8.04 that page already got. So what's potential difference? Potential difference is like the difference in the potential energy. So you can think of it as if when the current is flowing, the current, right, got carry energy coming from the dry cell. Then after that, it goes through the light bulb, convert the energy into light because light bulb produces light energy, right? Light energy. So after that, finish the energy already, then flow back, no more energy. So when you measure potential difference, you're measuring the difference in the potential between these 2 points. Let me just check, do they give you the definition for this? Not really lah. They didn't really give you the definition. I give you the definition so that may be easier for you to understand. Okay, so V is the voltmeter. You measure voltage and potential difference using unit volt lah. Okay, volt. This is your unit. I think I better write that out for you. Unit is measured in volts. I think I didn't do the current, no? Current you use ammeter. I think that's one I think you know already lah. You should know, right? If you want to measure current, you use ammeter. I think this one you know lah. Ammeter. Yeah. This one you use V, voltmeter, unit is volt. What actually is potential difference? Potential difference is the work done to move 1 coulomb charge between 2 points. Actually, this is the meaning for potential difference. So what happens is, because the charge is carrying, the current is carrying charge, what happens is, you imagine this way lah. Let's say if this is the current, I just put color for fun, okay? So here you got the current flow, current flow, current flow, current flow, current flow. Then what happens is here, then it is carrying charge. Then come here, it starts to do work. What is the work? Converting the electrical energy to light and heat. Come out, finish the work, done. Okay, then go home. So potential difference is the work done. That means this voltmeter is measuring what? It is measuring how much work done between these 2 points. Between these 2 points. What work? The work you can imagine is converting electrical energy to become light and heat. Hey, why I put N? Should put last side. Can you follow? Can oh, they didn't give, there's no calculation. Okay, that means not, maybe they not, I don't think it's in your book, so no whether it's in your book or not your book. Okay, never mind. So that's the work done. So just be aware lah, so that let's say next time you're confused again. So you always think, okay, current is flowing inside the circuit. It's flowing inside the circuit. So it's like, you imagine like water. This is a water pipe, the water flow. The water flow is like the current. Now, potential difference is you measure the amount of energy that they use. The energy for the water to flow from one point, go to another point, how much energy they use. So normally, for your syllabus, if got nothing, if only wire only, nothing else, you imagine no work done. It's just flow, smooth all the way, no work done. Then when it gets here, forced to do work because here got light bulb. If it's not light bulb, maybe it's a motor, forced to do some work. Maybe it's like a handphone, or need to charge the handphone. Okay, that's all that's work, because it needs to do something. It needs to produce some energy, like use up the energy to do something. Then that one is considered work for electrical circuit. Going through the wire is not considered work. It's considered like, okay lah, just go only, no work done for the electrical current. That's why on the next page, they put 2 light bulbs, right? So if you have 2 light bulbs in series, oops, I changed the color already. So what happens is, if you put 2 voltmeters, right, like this, let's say I put here voltmeter 1, and I put here voltmeter 2. Because these are 2 different parts in the circuit. Here is different part from here. These 2 doesn't not guarantee the same number, can be different number. Okay, so V1 and V2 sometimes it's not the same. So that's why you look in your book, page 179. Oh, you got one is 2 volts, one is 1 volt. Depends lah. Sometimes can be same, sometimes can be different. But if it's same, it's not because they are equal. It's more like so happen, coincidence, they are the same number. Otherwise, you must always assume, okay, they are different. They can be different. Okay, don't assume it's the same. However, if I put a voltmeter here like this, can you see V3 is including V1 and V2? You imagine like this. Let's say this is the current. If the current should be green color, not blue. The current flow. How much work done from this point until this point, So it goes through, do some work at V1. do some work at V2. Come on. Can you see that V3 is actually V1 plus V2? Okay, so V1 is not same as V2, it's not. But V3 is including V1 and V2. That's why it plus together. So when you look at your textbook, they didn't draw here. I know they draw here, but actually it's the same. Because if you see how this V is not across the dry cell. No, you cannot measure inside the dry cell. It's always outside the circuit. Here is the start. Go through all the way, come back. Here is the end. V is including V3 and V1 and V2. Come back. If got something else here, include that one also. No? So that's why you see here, they write there, 3 volts. 3 volts, why? Because it's 2 volts plus 1 volt combined together. I don't know why your book is showing you electron flow when it should be showing you current flow. Confuse people. I think I need to write my own book. I think I can do a better job. Shock sendiri uni lah. Okay, can follow so far? Can okay. Okay, so here's the thing. I want you to try the questions because I just want to see how much you can you know and you don't know. Because obviously if you just listen, you're like, okay, can get. Then the challenge is, can do the questions or not. Okay, can you do the questions or not? So here's what I want you to do. On the electricity section 8.04, currents in a simple circuit. You guys, you have 4 questions, right? That page, can you do the 4 questions? And then potential difference, there's 2 questions, right? Number 1, number 2. But got A, B, C, D, E and all that. I'm just reading the question again. How come they ask you to count this, but they don't give you the formula? They give you something, but they didn't give you the formula. Oh God. But they never write properly. No wonder I didn't see it. Okay. I explained the formula to you. Okay, so the formula here for potential difference. Okay, formula is not given in your book, but it's somewhere in the middle there. They got right there. PD voltage across the cell. You see on the left side the page. Then it says there, if PD across the cell is 1 volt, 1 joule of potential energy is given. In other words, 1 volt means 1 joule per coulomb. I don't know why they can't write this out nicely for you. So now I'll write out for you nicely. Potential difference, right, to calculate is basically work done divided by charge. It's like they're saying 1 volt is 1 joule per 1 coulomb. Because work is joules, you all know this, right? Work is measured in joules. Charge is coulomb, C. And potential difference, of course, is volts. So if you had to calculate, right, you use this formula. This is what your book say. 1 volt is 1 joule per 1 coulomb. But I think, don't think of 111 because otherwise when you see the number, sometimes don't know how to put the number, right? So you just remember like this. The potential difference, I'll put as V, symbol. Work is W, work done, over charge. Oh, you don't learn the symbol. Symbol is Q. It's not in your book though. Maybe don't use the symbol, others you all get confused. Just use this formula. So like if you have to calculate and all that, let's say they talk about later you do the question, what's this potential energy? What potential energy they're talking about? Potential energy, put it as the same as work. That means because work done is like how much work they use, right? You think of it as because work is a type of energy. So how much energy was used, they use up during the work done. So another way to calculate is you can count it as the work Work is how much energy they use up. So when they ask how much potential energy is lost, you can think of it as, instead of work, is the difference in energy. That means how much difference in potential energy. Look. It's like you think of it as, come back here, when the current is flowing, right? It's carrying potential energy, ma. Carry. Use up. Use the energy. Use, finish. Okay, 搞定, So if you have 2 light bulbs, it will carry the energy, carry. Start to do work. Do some work, lost a little bit. So V1 is how much energy was used up, how much potential energy they use. Still got energy, lor. Why? Because got some more work to do. Haven't finished work yet. Do some more work. Do some more. Then finish. Okay, now we go home. So you just think of it as the circuit is very clever. Right? When it got one only, you know how to use up the energy one time. If got 2, 3, 4, you know how to distribute the energy. Go here, use up little bit, but some more, use up, then finish. You know how to distribute the energy. Okay. Anyway, so the time now is 1:43. I know that I said I want to talk about resistance, but I think, tell you what, let's not do so many things today, because I want to check, can you solve the first 2, not current and potential difference? If you can, then only we go on to resistance. So can you do the work on these 2, 8.04, 8.05? You try. If you don't know, at least let me know, then we can discuss the answers. Can you try now and then you submit to me? I realize my chat is not showing. Can you all do this now and send to me?